In the previous lecture, we have discussed about first come, first serve scheduling, and we saw that first come, first serve scheduling is one of the simplest form of scheduling algorithms that we have, and we also saw how it works. Now, in this lecture, we will be discussing a solved problem on first come, first serve scheduling algorithm. Now, before we go into the problem, let us first recall that we had some disadvantages associated with this first come, first served scheduling algorithm. And what was that? So the main disadvantage that we saw with this first come first serve scheduling was that if processes of higher burst times arrive before processes of smaller burst times, then the processes of smaller burst times will have to keep waiting for a long time until the processes of higher burst times complete their execution. Now this is known as the convoy effect. So if processes with higher burst time arrived before the processes with smaller burst time, then smaller processes have to wait for a long time for longer processes to release the CPU. So this is what I just explained. And this disadvantage that we have is known as the convoy effect. This effect in which the smaller processes keep waiting for the longer processes to release the CPU is known as the convoy effect. Alright, now keeping all this in mind, let us go to the problem and see what is the problem and how can we solve the problem. So here is the problem. Consider the set of 5 processes whose arrival time and burst time are given below. So we have a set of 5 processes whose process IDs are P1, P2, P3, P4 and P5. And here it is given the arrival time and here is given the burst times of these 5 processes. Now the question is, calculate the average waiting time and average turnaround time if first come first serve scheduling algorithm is followed. So what we want to do here is that if FCFS scheduling algorithm is followed here, we have to calculate what is the average waiting time and what is the average turnaround time for these 5 processes. So when we discussed about the scheduling criteria, we have already defined and described what turnaround time and waiting time means. So we have to calculate the average waiting time and average turnaround time. So let us see how we can do this. So in order to solve this, first of all, we need to prepare the Gantt chart for these 5 processes. Now let us see how will the Gantt chart of these 5 processes look like. So coming to the solution, here I have shown the Gantt chart for these 5 processes that we have. So basically what a Gantt chart does is that it will show you when did a particular process get the CPU for its execution and when did it complete its execution. So from this we can understand and see that. So let us see. So here if we analyze this table, we see that P3, the process P3 arrived at time 0. So this was the first process to arrive. So we are following FCFS scheduling algorithm, which is first come, first serve. So the process that comes first must be served first. So P3 is the one that arrived first as it arrived at time 0. So P3 gets the CPU and it's doing its execution in the CPU. Now, how long does process P3 use the CPU? For that, we need to see the burst time of process P3. So we see that the burst time of process P3 is 3 units of time. So the process P3 will be executing for 3 units of time. So that is why we have shown this 3 over here. It arrived at time 0 and it got the CPU at exactly time 0 and then it executed for 3 units of time, and hence the completion time of P3 is 3 units of time, which is shown here. Now if you see here, next we have a blank or a shaded box. So the shaded box represents the idle time of the CPU. Now why do we say that this time is idle? So in order to find that, we have to see this Gantt chart and this table. Now if you look at this Gantt chart, here in the chart we see that at the 3rd unit of time, P3 completed the execution. Now if you look at this table, there are no processes that arrived at the 3rd unit of time. If you check the arrival times, you see that no processes arrived at the 3rd unit of time. So at the 3rd unit of time, when P3 completed its execution, the CPU is idle. It is free and it was sitting idle. Nobody was using the CPU. Now if you look at this arrival times again, after this 3 where P3 completed, what is the next arrival time that we have? It is 4. 4 is the next biggest number just after 3. And which process is that? P1. So P1 arrives at the 4th unit of time. So at time 4, P1 arrived and it got the CPU for its execution. So here we see that from time 3 to 4, nobody arrived. So that is why this portion is shaded and left blank, because this is the idle time of the CPU. Okay, now let's see. Process P1 arrived at time 4, alright, and what is the burst time of process P1? It is 5 units of time. Now remember that burst time means the time that a process needs to use the CPU for its execution. We have already discussed that. So P1 will execute for 5 units of time. So here P1 at the 4th unit of time got the CPU and it will execute for 5 units of time. So 4 plus 5 gives us 9. So the completion time of P1 is 9 unit of time. So at the 9th time or the 9th unit of time, P1 completed its execution. Now let us see which is the next process that is going to get the CPU. So we finished P3, we finished P1. Now if you see, P1's arrival time was 4. So what is the next unit of time that we have that is just greater than 4? If you look, it is 5. And which is the process? Process P5. So it arrived at the 5th unit of time. But if you look at the Gantt chart, we don't see any 5 over here. And why is that? That is because even though P5 arrived at the 5th unit of time, at that time, P1 was already using the CPU. The CPU was with P1 at that 5th unit of time. P1 was using the CPU up to the 9th unit of time. So exactly at P5 or exactly at its arrival time, P5 could not get the CPU and it was waiting for the CPU until P1 completed its execution. So once P1 completes, the next one to get the CPU is P5. So P5 got the CPU at the 9th unit of time when P1 completed its execution. Now if you see what is the burst time of P5, it is 4 units of time. So P5 will execute for 4 units of time, that is from the 9th unit of time plus 4, which will give us 13. So 13 is the completion time of P5. Now which is the next process that will get the CPU? So if you look at the arrival times, P5 was the one that just completed now. Now what is the process that arrived after P5? We see that there is 6 and again 6 here. That means both processes P2 and P4 arrived at the 6th unit of time. Now the question arises, since they both arrived at the same time, who will get the CPU? So in most of the systems, what they follow is that when two processes arrive at the same time, then the process with the smaller process ID will first get the CPU in case of FCFS scheduling algorithm. So if you look here, P2 and P4 both arrived at the 6th unit of time. Now who will get the CPU? The process with the smaller process ID. Here P2, 2 is less than 4. So P2 will be getting the CPU. So P2 got the CPU over here at the 13th unit of time when P5 just completed. And how long will P2 execute? P2 will execute for 4 units of time. So 13 plus 4 is 17. So P2 completes its execution at the 17th unit of time. Now what is the next one? Obviously it is P4, which is the last one, and P4 gets the CPU after P2 completes. And how long does P4 execute? It executes for 2 units of time. So 17 plus 2, which is 19. So P4 completes its execution at the 19th unit of time. So this is what we can see from the Gantt chart, and this is how you should be forming a Gantt chart for a particular set of processes according to the algorithms that they follow. Alright, now our question was to find the average waiting time and the average turnaround time. Now let us see how can we proceed and find out these two values. Alright, so here I have just made that table which we saw before a bit smaller so that it fits on the screen. It's the same table, and here we are going to calculate the average waiting time and the average turnaround time for this set of processes that we have. So before we calculate, let us know what is the formula that we need to apply to calculate the average waiting time and the average turnaround time. So first of all, the way to calculate the turnaround time is completion time minus the arrival time. So this is the formula that we need to apply to calculate the turnaround time of a particular process. The completion time, that means when it completed its execution, minus the arrival time, that means the time at which it arrived. So let us not memorize this formula, but let us try to understand how we arrive at this formula. So when we have discussed about scheduling criteria, we have discussed about this turnaround time. So what is a turnaround time? Turnaround time is the time that is required for a process to complete its execution from the time it first came to the ready queue until and unless it is completely finished or completely executed. So don't confuse it with the burst time. Burst time is a time that a process will take for its execution in the CPU, but turnaround time will include the entire time that a process takes to complete its execution. So that will include the waiting time when it waits for IO operations and all that. So turnaround time is the time that a process takes from the time it comes to the ready queue for the first time until and unless it completes its full and final execution, which includes all the time it waited for different things. So how do we calculate this? It is the completion time minus the arrival time. So completion time is the time a process completes its execution fully. So that includes the waiting time and everything. So for example, if we look at process P1, it completed its execution at the 9th unit of time. So that is the completion time for process P1. Now minus the arrival time. So when did process P1 actually arrive? So for that you have to look at this table here. So when did process P1 arrive? It arrived at the 4th unit of time. So the completion time, which is 9, minus the arrival time, which is 4, which is 5 unit of time, is the turnaround time for process P1. So that is how you calculate. So if you think of it, you can understand the completion time, that is the time that process took to entirely complete its execution minus the time that it arrived. If you subtract this, you will get the turnaround time. Alright. Now what is the next thing that we need to calculate? It is the waiting time. So waiting time can be calculated like this. Turnaround time minus the burst time. So waiting time is the time that a process spends waiting to get the CPU. Now we already calculated the turnaround time. So turnaround time is the entire time that a process takes to complete its execution. And from that, if we minus the burst time, that means the time that a process actually needs for its execution in the CPU. That is the burst time. So from the entire time it took, if we just subtract the burst time, which is the time that a process should actually take if it was just given the CPU for its execution without being disturbed and without it having to wait for anything else, then we will get the waiting time. So even this, don't try to memorize it, try to understand what is it. So the entire time it takes minus the time it actually takes in the CPU, the burst time. If you subtract these two values, then you get the waiting time. Alright, now we know the formulas, and now let us try to apply this in this set of processes and try to calculate the average turnaround time and the average waiting time. So here we have a table in which we will calculate the required values. So here we have the process IDs P1 to P5, and here we have the completion time, and here we will have the turnaround time and the waiting time. So the completion times can be easily seen from the Gantt chart, and we fill up looking at the chart here. So the process ID P1, it completes at the 9th unit of time. So it is 9, and looking at P2, it completes at 17th unit of time. So it is 17, and P3 at the 3rd unit of time, and P4 at the 19th unit of time, and P5 at the 13th unit of time. So that is how we fill up this column for the completion time looking at this chart over here. Now we have to calculate the turnaround times and waiting times for these processes one by one. Alright, let's see. For the first one, process P1, how do we calculate the turnaround time? So what is the formula to calculate turnaround time? We have it here. So it is completion time minus arrival time. So what is completion time? It is 9 unit of time. And what is the arrival time of P1? The arrival time of P1 was 4 unit of time. So what will be the turnaround time? It will be 9, which is the completion time, minus 4, which is the arrival time, which is giving us 5 units of time. So that is the turnaround time for process P1. Now what is the waiting time? So the waiting time is turnaround time minus burst time. So here we already found the turnaround time, which is 5 units of time. And what is the burst time? It is again 5 units of time for process P1. So what is the waiting time? It is 5 minus 5, which is 0. So we got 0 here. So let us just observe at the Gantt chart. Why did we get 0 for P1? So when you look at P1 here in the chart, P1 was not the first process to arrive, but at the time P1 arrived. When did P1 arrive? At 4th unit of time. At the 4th unit of time, the CPU was actually idle. Nobody was using the CPU. So as soon as P1 arrived, it got the CPU for its execution. So that is why P1 did not have to wait for the CPU. It got the CPU exactly at the time it arrived. So that is why the waiting time of process P1 is 0. Alright, now let's come to process P2. So P2's completion time is 17, and what is the turnaround time? It is completion time minus arrival time, which is 17 minus what is arrival time? Arrival time of P2 is 6. So what will it be? It is 17 minus 6, which gives us 11. And what is the waiting time? So the waiting time is turnaround time minus burst time. So what is turnaround time? It is 11. And what is the burst time of P2? It is 4. So what does it give? It gives us 11 minus 4, which is 7. Now similarly for P3, the turnaround time will be the completion time, which is 3, minus the arrival time, which is 0. Now what is it? So it is 3 minus 0, which is 3. And what is the waiting time? Waiting time is turnaround time 3 minus the burst time. What is burst time of P3? It is also 3. So it will again give us 3 minus 3, which is 0. Now again, if you observe this in the chart, P3 was the first process to arrive, so it did not have to wait for the CPU. It was the first process to arrive, and we assume that the CPU was free at that time. So it arrived at the 0th unit of time and it didn't have to wait. So it got the CPU at that time itself. Hence the waiting time is 0. Now let's do the same thing for process P4. For P4, the completion time is 19. And what is the arrival time? The arrival time of P4 is 6. So what will be the turnaround time? It will be 19 minus 6, which is 13. And what is the waiting time? The waiting time is 13, which is the turnaround time, minus the burst time of P4, which is 2. So that will give us 13 minus 2, which is 11. Now similarly for P5, the completion time is 13. So what is the turnaround time? It is 13, which is the completion time, minus the arrival time, which is 5. So that will give us 13 minus 5, which is 8. And let's see what is the waiting time. The waiting time is the turnaround time, which is 8, minus the burst time of P5, which is 4. So that gives us 8 minus 4, which is 4. So here we have calculated the turnaround times and the waiting times for processes P1 to P5 using this formula. Now the last step is to calculate the average turnaround times and the average waiting times for this set of processes that we have seen here. So now let's calculate the average turnaround time. It is very easy. We already have all the values here. It is 5 plus 11 plus 3 plus 13 plus 8 divided by 5. We are dividing by 5 because we are having 5 processes. So it gives us 40 divided by 5, which is 8 units of time. So the average turnaround time for this set of processes, while they follow FCFS scheduling algorithm and when they arrive at the particular arrival time as given in the question, is 8 units of time. This is the average turnaround time. Now similarly, the average waiting time can be computed here. The average waiting time is again 0 plus 7 plus 0 plus 11 plus 4 divided by 5. So it gives us 22 divided by 5, which is 4.4 units. So on an average, we have 4.4 units of waiting time. So the average turnaround time, that means the average time that a particular process takes to complete its full execution from the time it came to the ready queue for the first time till the time it completes its full execution, is 8 units of time. And then the average waiting time, that means the average time a process spends waiting in this case, is 4.4 units of time. So for this particular question, when the processes arrives at the arrival times as given to us in this question, this is the average turnaround time and the average waiting times that we get. So there may be other scenarios where processes with higher burst times have arrived before the processes of smaller burst times, and then the smaller processes end up waiting for a long time. So in that kind of scenarios, the average turnaround time and average waiting times will be much more than this. So as I told you, this FCFS scheduling algorithm, it is simple, but it is not very efficient because the average times that we calculate here can vary drastically depending upon when the processes arrives and what is the burst time of those processes. So I hope the way we solved this problem, finding out the average turnaround time and waiting times for this FCFS scheduling algorithm, was clear to you. Thank you for watching and see you in the next one.